Afternoon all of you, and let's try this beautiful problem. So we need to compare P and Q value. Before I go further, it's better to represent the given summation in a nicer form. So I can write this as 1 by n out r by n whole square. I'm dividing by r. So this gamma I am calling out by r by our usual notation, plus 13, and we have minus 7 times r by n. So let's call this expression P, and r is running from 3n to 4n minus 1. Right? So now, pictorially, what does it mean is, if I take the value of r, let's say as 3n, so I'm going to get 3a square plus 13 minus 7 into 3 times 1 by n, plus, again next term I'll put 3n plus 1, so that will be 3n plus 1 by n whole square, plus 13 minus 7 times 3n plus 1 over n, second bracket, and so on and so forth. The last bracket is 4n minus 1 over n whole square, by keeping 4n minus 1, plus 13 minus 7 times 4n minus 1 by n. This is how it will decode to. Now can we transfer this information in a geometrical fashion? So you can see each of this expression is working like something x square, so it's like x square plus 13 minus 7x. So that tempts us to investigate a function f of x. So let's roughly the graph of x square minus 7x plus 13. So we know the point at which derivative will die is 7 by 2. So the graph is symmetric about x equal to 7 by 2. So let's say we have a line x equal to 7 by 2. It's upward parabola. At 0 is 13. So roughly I can tell graph is symmetric about 7 by 2. Right? Now, what is the geometrical interpretation of the first term? So first term is the value of x at 3. So this expression is nothing but f of 3 into 1 by. Right? Second expression is nothing but f of 3 plus 1 by n times 1 by n. And the last expression is f of 4 minus 1 by n times 1 by n. So now this gives a feel to geometrically represent this, because first term I can represent as the height at x equals 3 into, let's say, this size of this interval as 1 by n. Right? So that will give me roughly this area. So this area bounded is the representation of the first object or first element. Similarly for the second element, now we have 3 plus 1 by n. So at that point we'll get this height, and this area is represented by the second member of this series, so on and so forth. And now let's talk about the last member. So if this interval is 4, so this guy simply means 4 minus 1 by n. So I'll go back, that depicts 4 minus 1 by n. So at that point we'll have an height, okay, and this represents again the area as shown in the diagram. The interesting point of this problem is, if we'll move further, 4 minus 2 by n, right? So the area represented will be as shown in the diagram. Now what we can see from the picture? We can see from the picture 7 by 2 is exactly in the middle of the interval 3 to 4, because the average of 3 to 4 is 7 by 2. So these rectangles are in the symmetrical location. I'm not telling rectangles are symmetrical, but they are placed symmetrically with respect to the line 7 by 2. Now the beauty of this problem, how we are going to conclude whether the sum of all these areas, right? Whether the sum of all these areas will be lesser than the area bounded inside the curve from 3 to 4, or it will be more than that. So I know now we have an expression 3 to 4 x square minus 7x plus 13 dx. So basically we need to compare this with the value of p. Now this is not very easy task over here, or at least it seems easy, because the function f of x is not having monotonic behavior in this interval. If the function is having monotonic behavior, then clearly we can see whether this sum of rectangles is less or more. Now what is happening till left of x equal to 7 by 2 is area is more, right? The sum of rectangles is more than the area under the curve, right? So area under curve AC if I'm telling. But after 7 by 2, you see the sum of rectangle is lesser than area under the curve, right? So if I'll add them, the overall sum of rectangle, which is series sub sigma of series. Now there is a big question mark, because how I'll compare this, whether it's less than or more than this integral values, right? And so we need to compare this, and series sum is p, right? So it's p versus this game. But here is interesting fact. So now I need to check whether the increase in area or the gain in loss of area at both point, so how it's happening. Okay, so in both case, especially in this case, what we can conclude. So let's take any one of the chunk. Let's take, if I take just this chunk over here, right? It's 3 to 1 over n. So clearly we'll have a point over here. Let's say that point represents, this particular point represents the value, okay, corresponding to 3. We are having the image 4 over here, right? So this height, the height at 4 will be exactly same as height at 3 from the symmetricity of this parabolic expression. Clear? So what I'm telling is this height is same as this height. The diagram is not completely up to the scale, but I hope you are getting my point, right? So now if I can compare the gain in area here, so you see this is a small part, the sided region which I have sided over here. So this much area is gained over here, right? So this is the extra area gain, let's call it. And this area, the sided part here, is the area that we have loss. So now we need to compare like whether gain is more or loss is more, right? Because that will give me a feel of what exactly is happening. You can clearly feel from here the gain is definitely greater than loss, like this, right? So since curve is going like this, so definitely the area that is gained is above the diagonal. It's like half of this rectangle plus something else, right? So the area gain is represented by this region, which is clearly gain is more than loss over here. So here we are gaining more, but here we are losing less, right? Because loss is happening under this curve. This is the loss, this is a depiction for loss, and this is depiction for gain, right? So since gain is more than loss, so overall what will happen, if we accumulate all these gains, so their summation corresponding will definitely be greater than all this loss over here. So overall integration will be more than the value p. So I hope you got this. So its p will be greater than, in fact integration will be less than, because gain is more, so overall integration value will be more. So since gain is more or less, so overall sum of area of rectangles, which is p, will be more than this integral value, and that integration value is already known in the question, right? Because all the options were just identical. So it's 5 by 6, so p is going to be more than 5, and hence the final answer to this problem is p greater than 5 by 6. Exactly with the same argument you can defend this, and you'll get q is greater than 5 by 6. Okay, so both answer is more than 5 by 6 over here. Now let's take one more problem of the similar kind, so that directly you can understand the application of this. And the second problem goes like this. If I take the first term of the series, it's nothing but 1 by n4 plus 1 by n cube. So let's say this gap is 1 by n. So that's the height I'm getting, right? And that into 1 by n. So we'll get this chunk as the area. Similarly, for next term is 2 by n. So it's 2 by n times. So I'm getting a little bit more area, right? 1 by n. Same, with the same logic we'll have 2 by n. So area of rectangles now 3 by n will always be more. And what will be the last point? N by n, it means up to 1 I'll get. Right. Now clearly if we'll add this area, since it's a strictly increasing function in this interval, so I can tell the area of rectangles, the sum of rectangles over here, summation from 0 to 1, of course, all these discrete rectangle sum is definitely more than the integration 0 to 1 of that function f of x dx. Right. And clearly from 0 to 1 f of x dx is 167 by 60. So we have 167 by 60, right? Now since it is true for all n, okay, because it will be true for all n, so hence it must be true for s 2025, because if the last term is 2025, let's say r is 2025, so we'll have 2025 by n. So you can divide it into many parts. Let's say this exact area will be when limit n tends to infinity, that summation, right? So here if I'll take limit n tends to infinity, this summation, that will go to 167 by 60. If it is not tending to infinity, is a discrete number of a step, whether it's 2025 or 2026, doesn't matter. So in fact it's true for any n, right? So Sn will always be less than 167 by 60 for all n belongs to natural over here. Okay, so that shows the value of Sn will be more than 167 by 60. So option B is correct. Similarly, now you can take the second option. So if it start from 0, if it starts from 0, the first term will give you f of 0 times 1 by n, right? So f of 0 will be exactly this side times 1 by n. Again, second term will give f of 1 times 1 by n. Third term will give f of 2 times f by n. And f of finally again 1. So now the sum of area will be definitely, so that is q, will be lesser than. So this area is Tn according to our notation. So it will be lesser than the integration 167 by 60. Right. So that solves the problem. In the first problem, the idea was more technical because some loss and gain manipulation has to be done. The second problem was quite straightforward, and the similar problem as second problem was directly kept in JEE Advanced. Right. If you want, I can give you one more questions, and probably you can have fun with this question, right? And the question goes like this. It is again based on Riemann sum, and it's interesting. Suppose if I define a function f of x such that f of x is limit n tends to infinity sigma k equal to 0 to n mod of x minus k by n. And we have 1 by n over here. Then we have to find the value of f0 and f of 1. So let's see how to go about this problem. This is again interesting one, because one way of doing this is directly you put f of 0 and the question gets converted into limit n tends to infinity 1 by n sigma mod k by n, where k equal to 0 to n. Now this is nothing but a standard Riemann sum. So if I'll take k by n as x and 1 by n if we'll denote with dx, so this problem becomes integral k0 corresponds to 0 and is 1 mod x dx, right? And that goes to 0 to 1 mod x dx, simply evaluates to 0 to 1 x dx, which is half, right? And exactly in the similar way we can find f of 1 as well. So to get f of 1, simply you put x equal to 1 over here, and now the given summation will convert into integration. K equal to 0 corresponds to 0, k equals 1 corresponds to 1, because you put k equal to n, we'll have n by n as x, and limit n tends to infinity. So that quantity is 1. This entire quantity goes to 1. So we have mod 1 minus x dx at x equals to. And how to evaluate it? It's very simple. Even geometrically you can feel, because at x equal to 1 we'll have 0. Between 0 to 1 is still positive. So the area of this triangle is precisely the answer, which is nothing but half into 1 into 1, which gives half as the answer. So this was not at all technical. It becomes very simple. Now what about f of minus 1? So then the integration I becomes 0 to 1. Right, minus 1 minus x dx. So it is same as 0 to 1, 1 plus x dx, which goes to 1 plus x dx, integration 0 to 1, because in this interval it will open as positive. So we have 1 plus half, which is 3 by 2. Right? So this is a way of doing this. In general, if you want to do this question, then it will be mod x minus, because it's a function of x, so it's mod x minus y dy, integration 0 to 1. And now how to open this? That depends on the value of y. Right? So we have interval 0 to 1. So if y is more than 1, if y value is more than 1, it will open as one way, because let's say y is 2. So it will always open as negative. If y is anyway between 0 to 1, then that depends. So I can open from 0 to y. Okay, let's say y is half. So then it will open from 0 to half, because 0 to half it will be negative, 0 to y negative, and then y to 1 is positive. And if y is less than 0, it will always open as positive. Okay. So by this you can find the piecewise definition of this function. Right? So sometimes it can also be, like kept in mod or sign or whatever. So still we can use Riemann. Let's try one more problem. And this is not precisely from integration, but also is very useful because sometimes linear programming can also be asked, like to relate with basic idea. So suppose if I have a set S which contains all x comma y belonging to R2, 2 ka power x, 4 ka power y, max value of this when x comma y belongs to set S. So again, it's very nicely created problem, because a similar problem came in JEE Mains. Not exactly in this form, but from linear programming. So it's basically questions from a straight line or linear equations. So let's first try to plot this curve, x plus 3y equal to 5. Right, so x plus 3y equal to 5 would roughly look like this. 2x plus y is 5, again it will roughly look like this. It's fine. And their point of intersection is going to be 2, 1. X greater than 0 means we are in this quadrant, y greater than 0, both together means we are in first quadrant. So now the inequality represents this region, right? So precisely this is the region which is expressed by the set S. So all points in set S precisely come from this region. Now the question is, if I pick up any point, so let's say I pick up this point over here. So there are infinitely many points. Okay, so let's say I keep point P1, P2, P3, even I can keep point 2, 1. So if I start calculating a value of 2 to the power x, 4 to the power y, so let's say for 2, 1, its value will become 2a square into 4 to the power 1, which is 16. Similarly, for P1 will have some value, P2 will have some value. So for all these infinite points which will be taken from this bundles, we'll get infinite possible value of 2 power x, 4 to the power y. We need to find the maximum possible value of this. So how to go about this? Look, I'll take this expression 2 power x, 4 to the power I as, let's say, some expression k. So now I can take log on both sides, because if k is maximum, log k must be maximum. Why? Because k log is a strictly increasing function. So when input is more, output will definitely be more, right? So this is going to give me 2 to the power, because k can be written as 2 power x into 2 power 2y. So it's 2 power x plus 2y. So we have x plus 2y ln 2. So fundamentally, I need to maximize x plus 2y value. Now let's take x plus 2y is u, right? It means at each and every point, now I need to find the value of x plus 2y. Clear? Now u will keep on changing. So let's say for u equal to 0, what is x plus 2y value? Okay, so for u equal to 0, x plus 2y will be 0. So let's say if I keep a point 0, 0, I get x plus 2y 0. So if u is 0, the curve that I'll get is y is minus x by 2. Right? So this is the curve that I'm going to get over here. Clear? So this is the actually the curve that I'm going to get roughly with minus half. Now you can see if I keep on changing this line, so this is a status for u equal to 0. It means if I'll take 0 comma 0, I'll get the value of u 0. Now what about, let's say, for this line? Again, I'm trying to draw parallel line. Is x plus 2y equal to sum u. Okay, and if u changes, we'll get this set of parallel lines, right? U changes, we'll get set of these parallel lines. So now for all these points on this line, let's say if I take any point p1, p2, p3, p4, p4, p6, p7, p8, for all these points the value of u is going to be the same. Why? Because line will satisfy the equation. Okay, so as long as xy is taken from here, I'll get value of u to be same. Now for the maximum value of x plus 2y is basically 2y is u minus x. Okay, so if I want u to be maximum, it's u by 2 minus x by 2. So at x equal to 0, we want to find actually maximum y height. It means for all these line, which line is giving me the maximum y intercept? That is going to be the answer. Now that will completely depend upon the line which are taking. Because let's say if the line is something like this, right? Then definitely it might be possible the maximum height I'll get as will be corresponding to the point 2, 1, right? And that's the case over here. Because if you'll see this, okay, if you'll see this condition, you will see the maximum height is going to occur when it passes through exactly the intersection point because of the curvature, because of the slope of the line x plus 2y. So hence the answer for this problem will be corresponding to x equal to 2 and y equal to 1. Okay, again I am repeating this for those who have not got this. So if we are having some region like this and its point of intersection is 2, 1, this is the region. Now it all depends upon, let's say if you need to maximize the value of x plus something like this line x plus 2y equal to something. So now this represents the set of parallel lines, right, according to the value of u. So for some given slope m, okay, x plus by, let's say I need to maximize. So I'm taking it some z. Z changes. So if z changes, the line changes. And it shows like for each and every point in this region, which is lying on this line, z will have a fixed value, right? This basically fixed values of z will be found over this line. Okay. So under this case, the red line will have maximum answer. It will give maximum possible value when the point is over here only, right? Because that will give maximum y-intercept. But let's say now if I change the curve, if I change the x plus by, like the optimal curve to be anything else, suppose this one, right? So under this case again the maximum value which I am getting is corresponding to this point, right? But it might be possible, like sometimes we'll get maximum value corresponding to 2, 1. Let's say if a line slope is parallel to this one, parallel to this line. So again all these lines, out of all these lines the maximum value will be coming for 2, 1. Right? Because what is the slope of this line? Slope of this line is minus 2. And what is the slope of this line? It's minus half. Right? And slope of this guy is minus 1 by 2. So from the slope, you can talk roughly what is going to be the orientation and at which point we'll get the maximum. And that's why the theory of your linear programming tells the maximum you will get at a corner points. It's because of this basic fundamental reason. And this is the heart and soul of linear programming, right? So I hope you have enjoyed the video and understood. If you are new to my channel, please do like and subscribe because that will justify the amount of work which I keep. Usually these kind of questions, because you are also into many institutes, you will not find at one place. Okay. In fact, most of the questions are new and especially incorporated in my book. Thank you. Have a good day.